Okay, normal distribution, that's the chapter topic. And in previous section, we discussed about the standard normal distribution. And in this section, we're going to see some application, real life application of normal distribution. Remember, there is a difference between, standard normal distribution and just a normal distribution. Okay. So you have a normal distribution with the bell shaped and with the mean and standard deviation. Uh, f- for the standard normal distribution, this mean should be 0 and standard deviation should be 1. Okay, but for the normal distribution, this mean could be anything and standard deviation could be anything. So that is the mean is not 0 or the standard deviation is not 1 or both. That's the normal distribution. So we are going to see some problems here in this section where the problems are taken from real life application. And in real life, what happens is the average, the mean could be anything. It's not supposed to be 0, but still we can solve a normal distribution problem by converting that into standard normal distribution by using this formula. Whenever you go from mean to g-score, you can go from normal distribution problem to standard normal distribution problem. So this is the formula you have to remember, the relation between g-score and the value x, any value. And the formula allows us to standardize any normal distribution so that x values can be transformed to g-score. So here is the picture you can see. Initially you have any x value, that's the value of some score. For example, let's say the figure illustrates the conversion from a non-standard to a standard normal distribution. The area in any normal distribution bounded by some score x, as you can see here, is the same as the area bounded by the corresponding g-score in the standard normal distribution. So this area under the curve and this area under the curve, even though we go from x score to the g score, the area would be same. Because the area is same, the probability of finding this event, the probability would be same. So we can use the same idea we use in a previous section to find the probability, but in this section we need to do one more step. That is, we have to go from non-standard normal distribution to the standard normal distribution using this formula. Okay. And as we discussed in previous section, we can use Excel, we can use table, we can use technology calculator to find out probability or area under the curve. So we can do the same thing here in this section, but if you want to use the same formula we used in previous section, first of all you have to go from value x to value g square. You have to go from non-standard normal distribution to the normal distribution. Okay, there is a one formula named norm.dist, normal distribution, in Excel. You can use the Excel too to solve this problem. We're going to use I'm going to at least I prefer to use TI-8384 calculator to solve this problem from this chapter, but I'm going to show you how to use Excel formula. And we already discussed how to use TI-8384 calculator and how to use the table and then Excel in previous section as well. So I strongly recommend you to watch previous section lecture video to continue this section as well. Okay. Finding values from known areas. If you have given areas under the curve and if you want to find out the g-score, okay, here is the thing. Graphs are extremely helpful in visualizing, understanding, and successfully working with normal probability distribution, so they should always be used. But don't be confused, the area under the curve and g-score, they are not same thing. Okay, the area under the curve is different than g-score. Here is the thing, you can find the area under the curve by using the g-score, or you can find the g-score by using the area under the curve, but they are not same thing. Don't be confused. and choose the correct right left side of the graph. Depending on problem or situation what you have told, you need to choose correctly which part of the graph you are using, right or left. A value separating top 10% from the others will be located on the right side of the graph. So let's say here the value separating top 10% means, let's say here it's a 10%, top 10%. But if you say value separating bottom 10%, then that should be here, bottom 10%. So you have to keep in mind which portion you are looking. You have to just focus on that thing. A g-score must be negative whenever it is located in the left half of the normal distribution. As you can see, if you are playing with the normal distribution, and if there is a mean and a standard deviation, and if you standardize that normal distribution, and if you go to the standard normal distribution, you see that the mean would be 0 and standard deviation is 1. Any value to the right side, that's the g-score positive. G-score positive. Any value to the left of this is g-score negative. So that's the negative g-score. So a g-score must be negative whenever it is located in the left half of the normal distribution. And keep in mind, area under the curve, or which is also probability, are always between 0 and 1, and they are never negative. So that's the difference between g-score and area under the curve. Area should be always non-negative. G-score could be negative. Okay, so how do we find procedure for finding values from known areas or probability? How do you find g-score using the area or probability? So first of all, you need to sketch the normal distribution curve like this. I sketch it. Enter the probability or percentage in the appropriate region. For example, let's say you have given this area, let's say, which is 35%. That's the area under the curve, which is 0.35 or 35%. And identify the x value. To find the x value for this one, first of all, you can find the g value, and you can go from g value to the x value. For finding the g value, you can use a technology like we discussed in previous section, or you can use table, you can use Excel sheet, and from g-score you can go to the x value. Okay, how do you do that? We know the relation between the g-score and the x value is this one, right? Just multiply both sides by sigma, which is standard deviation, and that gives you g times z times sigma equal x minus mu. And then from here you can just add mu both sides, and by doing that it gives you g times sigma plus mu equal x. So after finding the g-score, you can find the x by using this conversion formula. Refer to the sketch of the curve to verify that solution makes sense in the context of the graph and in the context of the problem. Always you need to do that. So these are the things you have to keep in mind while solving the problem in this section. But one of the most important thing you have to understand in this section is, in real life application, your mean and standard deviation could be non-zero, and mean could be non-zero, and then standard deviation could be not equal to 1. But still we can solve the problem by converting that problem to the standard normal distribution problem and using the technology to solve the problem. I'm going to show you a couple of examples in this section. So let's go to your homework problem from here. Let's say problem 1. Pulse rates of women are normally distributed with a mean of 77.5 bits per minute and a standard deviation of 11.6 bits per minute. Answer the following question. What are the values of the mean and standard deviation after converting all pulse rates of women to the g-score using this? Whenever we convert non-standard normal distribution to the standard normal distribution, that mu becomes 0 and standard deviation becomes 1. So the mu would be always 0 for the standard normal distribution, and standard deviation is 1. Okay, so next question. The original pulse rates are measured with units of bits per minute. What are the units of corresponding g-score? Remember, the g-score doesn't have any unit. So the g-score are numbers without unit of measurement. Okay. Let's look at another problem here. This is the normal distribution we have given. We need to find out x. We have given this area under the curve, which is 0.8. How do you find x? Remember, for finding the x, we can always use this formula. As you can see here, this is the conversion formula. And if you go back here, where is that? This one. For finding the x, you need mean, you need a standard deviation, and you need the z-score. So in this problem, you have given mean and you have given a standard deviation. Find the indicated IQ score. So we would like to find out the indicated IQ score, which is the value of x, such that the area under the curve, or the value less than that IQ score, is 80% of the value. Okay, that's the meaning of this 0.8. 80% of the value that is less or equal to this IQ score. So we would like to find out what is that IQ score. And we know that the mean is 100. So mean is somewhere here. So it should be greater than mean, because mean means the 50% of the value, 50% of the IQ score is less or equal to the mean. But here we would like to find out the IQ score, which is greater than 80% of the value. So how do you do that? First of all, find out the z-score using the table, or using the Excel, or using the calculator. We already know how to find the z-score using all these three different things. 80% area, so area means always inside this table, the body part. If you go to the first column or the first row, that gives you the z-score. We are trying to find out the 0.8 inside this body part. So if you look at the 0.8 here, 0.78, 0.80, this is the 0.8, which is for z-score 0.8, 0.05. So that means combined it's 8.05. Okay, but I always prefer to use calculator, so I'm going to show you how to use calculator as well. Let's say if you go to the second distribution, and then there is a number 3. That number 3 always gives you z-score if you provide the area. In this case, the area is 0.8, and this gives you the z-score such that the area under the curve to the left of that z-score is 0.8. So the z-score you can see is 0.84162123335. But our goal is to find the value of x instead of z-score. So how do you find x? You multiply that z-score by given standard deviation, and you add the mean to that value. So let's go back to the problem one more time. You multiply this z-score by standard deviation, which is 15 in this case, and you add the mean, which is 100, and then that gives you 112.62. Round to the one decimal place, it would be 112.6. Let me double check. Yes, so for IQ score 112.6, 80% of the IQ score are less or equal to that value. Okay, let's go to next problem. Okay, engineers want to design seats in commercial aircraft so that they are wide enough to fit 90% of all males. Accommodating 100% of the males would require very wide seats that would be much too expensive. Men have hip breadths that are normally distributed with a mean of 14.6 inch and a standard deviation of 0.9 inch. Find P90. P90 means that is find the hip breadth for men that separates the smallest 90% from the largest 10%. So this is what you want to find. Let me just use one blank page here. So here is the thing. You want to find out the value of hip, what is that? Hip breadth such that, you want to find out the value of hip breadth. So let's say the value of x such that 90% of the male men breadth should be less than that value. So you want to find out the value of x such that 90% of the value should be less than that value. So the area under the curve to the left of this value is 0.9. So remember, we can find out this information by finding the g-score for this, and then after finding the g-score, we can find the value of x by using the very same formula we use, which is x equal z times sigma plus mu. So first of all, find the g-score, and for finding the g-score using the area, you can use your calculator, you can use Excel, or you can use some other tools like the table. If you have given table, I always use this calculator. So I'm going to show you how to do that. Go back to the second variance, so that means distribution, and then use number 3, which takes the area, which is 0.9 in this case, to the left of that g-square and gives you the g-square. So g-square for this area, remember this g-square is coming from the area to the left of that g-square. So this 0.9, which is 90%, should be to the left of that g-square. So g-square is 0.1.28. For this g-square, what is the value of x? For that, you are just multiplying this by sigma, which is in this case 0.9, which is a standard deviation. So I'm going to multiply this answer by 0.9, and then I'm going to add a mean, which is 14.6, to this value, which is 15.75. So the meaning of this is 90% of the men breadth should be less than 15 points. The hip breadth should be less than 90%. Men have hip breadth less than this value, which is what is that? Which is 15.8 if you round it to the one decimal place. 15.8. Okay, let's go to next problem. Let me just pick this one. A common design requirement is that an environment must fit the range of people who fall between the 5th percentile for women and 95th percentile for men. In designing an assembly work table, the sitting knee height must be considered, which is the distance from the bottom of the foot to the top of the knee. Males have sitting knee heights that are normally distributed with a mean of 21.9 and a standard deviation of 1.1 inch. Females have sitting knee heights that are normally distributed with a mean of 19.1 and standard deviation is 1.0. Use this information to answer the following question. So here we have given two sets of data. From the first set, which is for the men, the mean is 21.9, standard deviation is 1.1, and for the for the second set, that's the data for females, where the mean is 19.1 and then standard deviation is 1.0. In our case, we need to find out what is the minimum table clearance required to satisfy requirement of fitting 95% of men. Remember, 95% of the data should be less than the value you are picking for the men. So how do you do that? Okay, we would like to find out there is the normal distribution. Make sure that you draw complete normal distribution here. There is you would like to find out the value x, which is the height of here is the what we're trying to design here. It's the sitting knee height must be considered. So sitting knee height, which is the distance from the bottom of the foot to the bottom of the knee. Okay, when you when the men, they sit on some kind of chair. Okay, let's say there is a chair. Okay, there is a chair, I don't know how to draw it properly, but I'm just trying my best. And someone sits here, and when that man sits here, there is a feet, and then we're talking about height of height, which is the distance from the bottom of the feet to the top of the knee. So this is the distance we're talking about, from the bottom of the feet, this is the feet, and top of the knee. Okay, this is our x. So we would like to find out what is the value of x, what is the height supposed to be, such that 95% of the men would have less than that height, that x. We would like to find out this x. So the meaning is 95% of the data should be less or equal to x. So that means the area under the curve to the left of this value of x is 0.95. We don't know how to use technology to find the x, but we do know how to use technology to find the g-score. And then after finding the g-score, we can go to the value of x by using this formula, x equals z times sigma plus mu. Okay, by using the very same idea, we're going to use this this inv norm function, which is number 3. It takes the area under the curve, which is 0.95, and gives you the g-score. This is the g-score. And now for finding the value of x, you multiply this by standard deviation for the man, which is 1.1, and then add mean, which is 21.9, and that gives you the value. So if the value of x, the height we take is 23.7, rounded to the 1 decimal place, inch, 23.7 inch, then 95% of the men could use that chair. Okay. Oh, table, work table. Okay, it's a table. So now determine if the following statement is true or false. If there is a clearance for 95% of males, there will be certainly the clearance for all women in the bottom 5%. So we would like to find out, first of all, it looks like it's a trivial, but we need to find out what is the value of x for which you get the 5%, bottom 5%. So bottom 5% means let's say, no, that's not, I want to add some. Okay, so for the woman case, we would like to find out that too, and we are going to compare that value. So for the woman case, we have given, so for bottom 5% means we would like to find out x such that to the left of this x is 5%, meaning 0.05. The area under the curve is 0.05. And for woman case, the mean is given, which is what is that, 19.1, and then standard deviation is given, which is 1. So in this case, we don't know how to find the x using the technology, but we do for finding the g-score, which is in our case I'm using calculator second, and the very same function second, and distribution number 3. And if I put 0.05, which is 5%, to the left of that g-score, which is negative 1.64, and that is the g-score. And for finding the value of x, I need to use z times sigma plus mu for the woman, which is in our case I'm going to multiply this by sigma, which is 1, plus the mean is 19.1. So anything less than 17.455%, less than 17.45 inch would be in that 5% less than 5% percentile rule. So what is that? Determine if the following statement is true or false. If there is a clearance for 95% of males, so that means 95% of the males, if you design 23.7 inch, then 95% of males would fit in that design. Because this number we got for the female is, where is that? What is the number we got? Here, which is 17.455, which is less than this value 23.7. So that 5% percentile rule for the women would also fit for this design. So what is the answer? The statement is true because some women will have sitting knee heights that are outlier. No. The statement is true because the 95th percentile for men is greater than 5th percentile for women, and that's what we saw. 5th percentile for women is 17.455. Okay. The author is writing this exercise at a table with a clearance of 23.8 inch above the floor. What percentage of men fit this table? Okay, so now we would like to find out, what percentage of men fit this table. Look at here. The author is using, in this case, the author is using the value of x equal 23.8. Okay, which is more than 95%. So the answer should be more than 95%. But how do you find it? First of all, to find this percentage, you can always find the g-score. G-score is x minus mu over sigma, and using that g-score you can find the area under the curve. So what is the value of g-score using this? So in our case, x is 23.8 minus this is the case for men, so the average for the men is 21.9. Hit enter and divide it by the standard deviation for the men, which is 1.1. That is the g-score we have. We would like to find out what percentage would fit for this value, less or equal. The author is writing this exercise at a table with a clearance of 23.8 inch above the floor. What percentage of men fit this table? So now to find that, you have to find out the g-score by going here, use the number 3, which is inverse num, which takes you need to find, you have the g-score, you want to find out the area, so it's not the right formula. So you have the g-score, you want to find out the area. So how do you find that? Go to let me just delete this. Okay, go to second distribution, that is number 2. Take number 2, that gives you the area under the curve. If you take two value for the g-score, in our case there is no 2 value, there is just one g-score, which is 1.72. but we would like to use this normal CDF function. It takes lower value. In this case there is no lower, so take something very small number, negative number. I would always take negative, let's say 10,000. That will be okay somewhere here. And then the highest one is 1.72, which is coming from the answer from the top one. So I'm going to use second and this button, which takes the answer from here, comma. Now here is the thing, this normal CDF takes 4 different inputs. This function normal CDF takes lower value, upper value, mu and sigma. If you remember the previous section, this mu and sigma are, we did not use anything for mu and sigma because our distribution was standard. But here this is not the standard distribution, so you need to use the value of mu and sigma given here. For this man, the value of what is that, mean is 21.9, and then the value of sigma is 1.1. So by using that, now it's going to give us, okay, what percentage of what is that, did I do something wrong here? It takes 1.72. No, okay, I did a mistake here. The mistake is this normal CDF, if you want to use the actual mu and sigma, you have to use the actual value for the lower and upper. You have to use this x 23.8. Let me just do that. You don't have to find the g-score. It will do it for you, this function normal CDF. So go to second, and then again the very same thing, very same function. The lower one is negative, let's say 10,000, comma, the upper one is 23.8. Use the actual actual value x 23.8, and then use the average 21.9. That's what we have given. Use the standard deviation 1.1, and then it gives you the answer, which is 0.9579406. Okay, so that is the answer for this one. What percentage of men fit this table? It's if you round it to the 2 decimal place, this is 95 point. If you multiply this answer by 100, that will give you 95.79. If you want to round it to the 2 decimal place, it's a 95.79. 95.79. Okay, so remember, we can use this g-score, the way I did the before here. We can use the g-score as well, but in that case we don't have to use mu and then sigma, because g-score means the standard deviation, standard normal distribution, which means mu is 0 and sigma equal 1. So if you want to use g-score for this function normal CDF, don't use mu and sigma. But if you want to use actual x for this function, then you don't have to worry about converting it into g-score. Okay, what percentage of women fit this table? So for this, you can always go back again and then use the very same function, which is normal CDF. It takes the minimum, which is in this case, let's say it's a 10,000. You could also use any very small negative number to cover all the graph under the curve to the left of x. So comma, the maximum is 23.8 in this case, but for the average for the woman, it's 19.1. it's given average for the woman, and then standard deviation for the woman is 1. So what percentage of women will fit here? It's a 0.999. So if you multiply it into 100, that will give you the percentage 99.99. and if you round it to the 2 decimal place, it would be actually 100%. Practically speaking, there is no 100%, but this calculation gives you the 100%. Does the table appear to be made to fit almost everyone? The table will fit only 4% men. No, that's not right. The table will fit almost everyone except 4% of the men. That's not right. Table will only fit 1% of women. No. Not enough information to determine if the table. Okay, look at here. Let's go here. 95.79% men are okay with this table, and 100% women are okay with this table. So the only problem is the almost 4%. So the table will fit almost everyone except 4%. So this is the right choice. Okay, so that's the problem, and let's look at another problem here. Where would a value separating the top 15% from the other value on the graph of the normal distribution? Top 15%. So if you have normal distribution, top 15% means somewhere here. To the right of this, it's a 0.515. So top 50% means it's the right side of the horizontal scale of the graph. The left side, no, it's a right side. What condition would produce a negative g-score? A g-score, if you look at the standard normal distribution, g-score means mean equals 0, standard deviation equal 1. To the left is negative g-score. To the right is positive g-score. Negative, it's a positive. So g-score corresponding to a negative area. What condition would produce a negative g-score? A g-score is corresponding to a value located to the left of the mean. Yeah, this is the right answer. Okay, so this is application of normal distribution. The one last thing I would like to mention one more time. This is exactly same as previous section, but the only thing you have to do is you have to convert your non-standard normal distribution to the standard normal distribution by using this formula, and you will be fine.